Okay. Hello, everyone. We have our first day of notes done through these online lessons. We're going to see how this goes. Remember, you can always pause the video or, rewind or fast forward if I'm going too fast. So feel free to, sort of do you with this. And if you need to rewatch the whole thing again, feel free to rewatch the whole thing again. All right, I'm going to get going here. And so we're just going to jump into some vocab. So the first thing we're going to talk about is what we're talking about: set theory and Venn diagrams today. This is a new unit. This is probability. The first of the four new vocab terms is set. A set is a collection of stuff or things. Doesn't sound very mathematical. This could be numbers. So it could be like we could have the numbers 1, 5, 12, 18. That could be a set right there. I could just say we're using this set. But it could also just be stuff. Maybe like I could have a set of shirts, pants, and shoes. So, a set doesn't have to be numbers. It could be items. It could be letters. It could be many things. So next up, universal set. This contains everything we are talking about. Some examples of universal sets: all odd numbers. Another example of universal sets: all letters. Those are examples of universal sets. Those aren't the only universal sets, but those are examples. Then we have subsets. These are pieces I don't know if I spelled pieces right. Is it E? I don't know. Set with, so pieces of the universal set, sets with the universal set. For example, a subset of this universal set right here of all odd numbers would be all odd numbers below 10. So that would not be all odd numbers. That would just be the odd numbers below 10. That is a subset of this universal set. Let's see here. So if we had a universal set, I'm just going to make one up here real quick. If we had a universal set of 1, 2, 3, 4, a subset of this could be 2 and 3. Or it could be 1 and 2, or it could be 3 and 4, or 1, 2, and 3, but just part of the universal set. And then we have this complement. This is all outcomes that are not in the selected set. This is kind of weird. There's notation for this. Sometimes they put a little line above it. Sometimes they put a little prime right next to it. An example, this is kind of a tricky concept. So let's say we have a set of all even numbers. The complement to this set would be all odd numbers. All right, a few other things we need to talk about here. We have relationship of sets. So let's see here. Intersection. Well, this would be only what is in both sets together. So if we have two sets and we have an intersection of these sets, then we are looking at the numbers that are in both of those sets. So let's say, so think of intersection as sort of an and statement. It's in this and this. We have a symbol. It's an upside down, sort of like an upside down U. If you look at it carefully, it kind of looks like an A. And starts with the letter A. So when you see this sort of upside down U that looks like an A, we're thinking of and. And so an example, if we have two sets right here, set C is composed of 7 and 8, and set D is composed of 7 and 11. What is the intersection of C and D? Basically, what is in both of these sets? 7 is in both of these sets, so the intersection here would be 7. Then we have the term union. So union is everything in either set. So think of union as or. That symbol is sort of like the symbol up here, but it's sort of a right side up U. It's not a U, but you know, it is a union, so I don't know, it starts with letter U, but it's everything in both sets. So the union of C and D would be all the terms in both of these. So if I write out my terms in C, we have 7 and 8, and my terms in D, we have 7 and 11. This is a little redundant. We don't count the same thing twice, so we're not going to count that 7 twice. So really, it's going to be 7, 8, and 11. Those are the numbers in C and D. We wouldn't say 7 twice. All right, if we go to the next page. We have some examples here. Suppose a universal set consists of all single-digit whole numbers. Two subsets are created from the universal set, the set of all even numbers and the set of all odd numbers. All right, I don't want you to get too hung up here on what the whole numbers are. I'll write this out real quick. So the universal set here of all whole numbers start at 0 and just sort of go up. You're talking all the whole numbers. So no fractions, nothing like that. And it would go all the way up to whatever the highest number you can think of. It goes up forever. So our two subsets are going to be our even numbers and our odd numbers. So our even numbers are going to consist of 2, 4, 6, 8, all the way up. Our odd numbers are going to consist of 1, 3, 5, 7, all the way up. So these are our even numbers. This is a subset of the universal set because these numbers are in this universal set, but it's just a subset of them. And odd numbers also a subset, same deal. All right, so now we have this, we have to find the intersection and we have to find the union. So this is the intersection. And the intersection means what numbers are in both of these sets. So what number is both in the even subset and in the odd subset? Well, none. There's no number that is going to be an even number and an odd number. That goes against the whole concept of it. So this is going to be none. If we want to find what is the union of these two sets, so basically we want all the numbers in either set. It doesn't have to be in both. We want all the numbers in either set. We're going to include all the numbers that we see here. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, all the way up. Notice there's no 0. 0 is neither even or odd. So that's sort of the one thing that got left out from the original universal set. All right, next up we're going to talk about Venn diagrams. A Venn diagram is a visual display that helps organize the relationship between two or more events. And basically, we're going to just talk about these, intersections and unions some more. And we're going to sort of try to look at it visually. So if I kind of lost you on the previous part, it might sort of open up here. So what we have here is we sort of have two groups of sets. We have set A, it's represented all the stuff inside the circle. And we have set B, which is all the stuff inside the circle with B. If I want to know what is the union of these two sets, what are the numbers in both of these sets combined, so it doesn't have to be all the numbers in just A and all the numbers just B, but all the numbers in both A and B, it would be everything in this circle, so it's all the stuff in the circle A, and it's also going to be all the stuff in circle B. So the union of A and B is everything inside set A and everything inside set B. If we're doing the intersection of A and B, we want just the items that are in both. So I wouldn't shade everything. We're just going to shade this sliver right here where we can see that everything inside this area is both in set A and also in set B. So that's sort of a visual representation of the intersection and the union. If we want to do the complement, so we mentioned this term complement before. A prime means everything not in A. So here's the set A. It's in this circle with the A. So everything over here is obviously not in A. But also, this little box right here contains stuff that is in neither A or B. So it's everything on the outside as well. I don't know why I'm being so picky. So everything not in A would be everything sort of in this population, but not the stuff in set A. And set A is being represented by this circle. So if I say B prime, well, that's going to be everything not in B. So that would be everything over here. But when we get to circle B, we want to leave that alone. So everything outside circle B. If we're doing if we are doing the, A prime and B, so we're doing the intersection of A prime and B, what is everything that is not in A and everything in B? So everything, I'm gonna write this out. Everything not in A and in set B. Okay, so everything not in A would be all that stuff on the outside, kind of like what we did right here. But but it has to be everything not in A and it's also in B, so it's just gonna be this area right here. That's everything not in A, but also inside of B. This is gonna be very similar. This is everything sort of in A, but not in B. And this would just be this guy over here. So everything in A, but not in B. This is the only things that are in A, but not in B. This is so now we're talking about the union. So we're talking about everything not in A and everything in B, and it doesn't matter if they don't have to be in the same spot, but everything not in A and everything not in B. So everything not in A, this would represent everything not in A. But it's also going to include everything in B. So this guy over here kind of gets shaded in because he's in B. I know he's not in A, but it's everything not in A and everything in B. So now he kind of gets counted. Same deal over here. The union of everything in A but not in B. So everything in A is right here, and everything not in B would be sort of this same area we just shaded here, but also all this outside. Number 9, this is sort of tricky. We're doing the complement of the union of A and B. So we already did the union of A and B. Union of A and B was up here in number 1. So if we're doing the complement of the union of A and B, it's everything that's not in this shaded area right here. So it's going to be just the outside part. If we're doing the complement of the A and B, so everything that's in both of these things. So we already did the intersection of A and B. So that was just this little sliver right here. These are all the things that are in both. If we're doing the complement, it's everything except what was the intersection of A and B. So the complement of this is everything except where they sort of intersect. So it's going to be everything right here. The complement is just everything else except what the answer is. So the intersection of A and B is just a sliver in the bottom. So the complement is everything except the sliver, sort of between the two of them. All right, we're going to do a couple more examples here. Let's see here. If the Venn diagram below shows the number of people in a fine arts club who are in band and choir, make the following determinants. Okay, so this is a little confusing looking. Here's what we got. We have two circles. They represent two different sets. This first circle represents all the people that are in band. This second circle represents all the people that are in choir. This number on the outside are the people that are in fine arts but not in the band or the choir. And then this little sliver in the middle represents the number of people who are in both. So we have 24 people who are just in band. We have 16 people who are just in choir. We have 2 people who are in band and choir. And then we have 8 people who are not in band or choir. Ooh. So how many people are in the Fine Arts Club? Why don't we come back to that in a minute? This little find the probability of B. All right, what that's asking us basically is just how many people are in the set B. Well, we have the 24 people that are just in band, and we also have 2 people who are in band and choir. So we have 26 total people. That's 24 plus 2 who are in band. That's what this is asking us for. When it says find the PB, it's just asking us how many things are in that set. All right, let's see here. Find the probability of the intersection of, or find how many are in both the intersection of B and C. So that is just going to be 2. We have 2 people who are in B and C. So we'll put 2 there. Find the probability of B or C. So how many people are sort of in band or choir? And this is where things can get a little tricky. We have 24 just in band. We have 16 in choir. And then we have 2 who are in both. We don't want to count this number twice. We don't want to say we have 26 in band and 18 in choir. We want to say we have 24 in band, 16 in choir, and then we have 2 that are in both. That's going to be the union of those 2 things. We don't want to count these 2 people twice. We only want to count them once. So 24 plus 16 plus 2, that's going to give us 42 people. And then finally, what is the complement of B? So basically, how many people are not in band? Well, we have 26 people in band. We have the 24 that are only in band and the 2 that are in band and choir. So how many people are not in band? Well, we have the 16 over here that are just in choir and the 8 hanging out over here that are not in either. So 16 plus 8 is going to be 24 people who are not in band. All right, so how many people total are in the Fine Arts Club? So basically, we had the 24 people who are just in band. We have the 16 people who are just in choir. We have the 2 people who are in band and choir. And then we got the 8 people who I guess don't do band or choir. I don't know what they're doing. If they're not doing, I don't know what, I guess they could be doing art. Who knows? But you would add all these numbers up and you would get 50. So that's that first example. All right, let's do a second one real quick. A guidance counselor is planning schedules for 30 students. 16 want to take Spanish, 11 want to take Latin. 5 say they want to take both. Display the information on the Venn diagram. Okay, let's see here. We have 16 people who want to take Spanish, 11 people who want to take Latin, and 5 say they want to take both. So this can be a little tricky. We definitely have 5 in the middle here. All right, we have 5 people who want to take both Spanish and Latin. So that's pretty easy. We got to think carefully, though, now what's going to go in this Spanish and this Latin circle. We had 16 people that want to take Spanish, but 5 of these 16 are not only wanting to take Spanish, they also want to take Latin. So that means there are only 11 people who want to take just Spanish. So basically what I did to get that 11 is I said 16 minus 5 is 11. I took out the 5 that want to take both, and I took that out from 16, and that leaves 11 people who only want to take Spanish. We're going to do the same thing for Latin. There were 11 people who wanted to take Latin, but 5 of those people wanted to take Latin and Spanish, so I'm going to subtract out the 5 here, and we have 6 people who want to take Latin. All right, the last thing we need to do before we answer these questions is basically answer how many people don't want to take Spanish or Latin. We had 30 students that we were planning schedules for. How many people have we accounted for so far? Well, we've accounted for 11 that want to take Spanish, 5 who want to take both, and 6 who want to take just Latin. So 11 plus 5 is 16, 16 plus 6 is 22. So we have 22 people total in here. We had 30 students total. So that leaves 8 right here. There are 8 students who don't want to take Spanish or Latin. All right, so now let's answer our questions. Find sort of this P, this probability of S and L. So this is the intersection question. What is the probability that a student wants to take both Spanish and Latin? Well, we already wrote that in here. There are 5 students who want to take both Spanish and Latin. What is the probability that a student wants to take Latin? Well, again, we have 5 that want to take Spanish and Latin, 6 that want to take just Latin. That gives us 11 total. There are 11 total students who want to take Latin. What is the probability that a student studies at least one subject? So basically, what is the probability of Spanish or Latin? So basically, either one. So this is that union. It doesn't have to be in both, where you want to count everybody that's in, one or the other. So we had 11 people in Spanish, 6 people in Latin, 5 in the middle. We just want to add the 11 plus 5 plus 6. We don't want to count this 5 twice, because we don't want to count those 5 people twice. We're just counting them once, and if we count that up, we're going to get 22 people. That's how many people are taking at least one subject. What is the probability that a student studies exactly one subject? Okay, so now we're going to take out the 5 in the middle. They're studying 2. They're crazy. We're going to look at the people studying just Spanish and the people studying just Latin. So that's going to be 11 plus 6, which is 17 people. And finally, what is the probability that a student studies neither subject? So basically, we're finding the complement. What is the complement of the union of people studying Spanish or Latin or both? Well, that's those 8 folks right here. These 8 people sort of hanging out, not studying Spanish or Latin. That's the complement of the union of people who are studying Spanish or Latin. So there are 8 people. There are 8 students who are studying either subject or neither subject. All right, that concludes the notes for today. Good deal.